Dear students, welcome to my classroom. In previous class, we learned how to find the sum of given numbers in an arithmetic progression. Sum of n terms of an arithmetic progression is denoted by Sn and is equal to Sn is equal to n by 2 into 2a plus n minus 1 into d, or n by 2 into a plus l. And also we solved some problems in exercise 6.3. And in this class, we are going to solve some more problems in that exercise. Take the third one. And in third one, we have in an AP, given A is equal to 2, D is equal to 8, Sn is equal to 90, find N and An. It is given that first term A is 2, common difference D is equal to 8, and sum of n terms is 90. Then what is the value of N? And find An also. This is the question. So students, in given AP, we have first term is A equal to 2, and the common difference is D is equal to 8. And also, given that sum of n terms, that is Sn, is equal to 90. And we know that the formula for finding Sn is n by 2 into 2a plus n minus 1 into d. So we have n by 2 into 2a plus n minus 1 into d is equal to 90. One more formula we have is n by 2 into a plus l, but we don't know the value of L here. That is the last term. So we have to take here n by 2 into 2a plus n minus 1 into d. And we have a is equal to 2 and d is equal to 8. So we can substitute these two values in this equation. So this implies we can write n by 2 into 2 into a is 2 plus n minus 1 into d is 8 is equal to 90. And from this equation, we can write by transforming 2 to right side, n into 2 to the 4 plus n into 8 is 8n minus 1 into 8 is minus 8 is equal to 90 into 2. So that is n into 8n plus 4 minus 8 is minus 4 is equal to 90 to the 180. Now we can take 4 common in this equation on left side. So by taking 4 common, 4n into 2n minus 1, 4 to the 4 1 the. That is 4n into 2n minus 1 is equal to 180. And by transforming this 4 to right side, n into 2n minus 1 is equal to 180 by 4, and we have 180 by 4 is equal to 45. So now n into 2n square plus n into minus 1 minus n, 180 by 4 is 45. And by transforming this 45 to left side, we have 2n square minus n minus 45 is equal to 0. So here we have to find n. So we can observe that this 2n square minus n minus 45 equal to 0 is a quadratic equation in the variable x. And by solving this equation, we get two values for n. Okay. So we can solve this equation in three methods: by completing root, and second one is by splitting into factors, or using quadratic formula. So let us use quadratic formula to find the value of n this equation. And we know that roots of the equation ax square plus bx plus c equal to 0 are minus b plus r minus under root b square minus 4ac by 2a, isn't it? So this is the quadratic formula to find the value of x in the equation ax square plus bx plus c equal to 0. And by comparing our equation 2n square minus n minus 45 equal to 0 with ax square plus bx plus c equal to 0, a is equal to 2, b is equal to minus 1, c is equal to minus 45. So that now n is equal to minus b plus r minus under root b square minus 4ac by 2a. That is minus of b is equal to minus 1 plus or minus under root b square, that is minus 1 whole square, minus 4 into a is 2, and c is minus 45 by 2a, that is 2 into 2. So minus into minus plus 1 plus or minus under root 1 Minus 1 square is 1. Minus into minus plus. 4 to the 8 into 45 is 360. So in that way, we get 1 plus r minus root 1 plus 360 by 2 into 2, 4. And we know that root 1 plus 360 is, that is 361 is 19. Okay. So we have n is equal to 1 plus 19 by 4 or 1 minus 19 by 4. That is 1 plus 19 by 4 is equal to 20 by 4, that is 5. And 1 minus 19 by 4 is equal to minus 18 by 4, that it can be written as minus 9 by 2. So here we got two values for n. One is 5 and another is minus 9 by 2. And students, here n is the number of terms. So number of terms cannot be negative and it must be a natural number. Okay. So as n cannot be negative, we can take n is equal to 5. So in that way, we got n is equal to 5. And one more we have to find is an, that is nth term of the progression. So now an is equal to a plus n minus 1 into d. That is by substituting n is equal to 5 here, a is equal to 2, d is equal to 5, and n is equal to, sorry, d is equal to 8 and n is equal to 5. We get 2 plus 5 minus 1 into 8, which is equal to 2 plus 32, that is 34. So now we got n is equal to 5 and nth term an is equal to 34. So let us take the next problem. That is sixth one. Given an is equal to 4, d is equal to 2, Sn is equal to minus 14, find n and a. This is the question. Here nth term of the progression is given, an is equal to 4, common difference d is given as 2, and sum of n terms is minus 14, and we need to find the value of n and the first term a. So students, in the given AP, it is given that common difference d is equal to 2, and also it is given that an is equal to 4. And we know that an is equal to a plus n minus 1 into d, which is equal to 4. And by substituting d is equal to 2, we get a plus n minus 1 into 2 is equal to 4. Now, a plus 2n minus 2 is equal to 4. And it can be written as a plus 2n is equal to 4 plus 2, that is 6. And that implies we can write a is equal to 6 minus 2n. So take it as equation 1. And it is also given that Sn is equal to minus 14. That is sum of n terms. So as we know the last term, an, we can take formula for Sn as n by 2 into a plus l. So n by 2 into a plus l is equal to minus 14. That we don't know the value of n and a. We know the value of l here. L is an, which is equal to 4. So substitute l is equal to 4 in this equation. So n by 2 into, we have a equal to 6 minus 2n from equation 1. Okay. So from equation 1, a equal to 6 minus 2n and l is equal to 4. So n by 2 into 6 minus 2n plus 4 is equal to minus 14. That is equal to n by 2 into 6 plus 4 is 10 minus 2n is equal to minus 14. By taking 2 common, 2n into 5 minus n by 2 equal to minus 14. And by cancelling 2 in both numerators and denominator, we remains with n into 5 minus n equal to minus 14. And n into 5 is 5n plus n into minus n is minus n square is equal to 14. And it can be written as n square minus 5n minus 14 is equal to 0, which is the quadratic equation in the variable n. So we shall solve this equation by splitting it into factors. So take minus 5 and minus 14. So we can write it as minus 7 plus 2l, because minus 7 plus 2 is minus 5 and minus 7 into 2 is minus 14. So in that way, we splitted minus 5n into minus 7 plus 2n. Now take n n common in first two terms and 2 common in second two terms. So by taking n common in first two terms, we get n into n minus 7. And by taking 2 common in last two terms, we get 2 into n minus 7 equal to 0. And n minus 7 is the common factor here. So taking n minus 7 common, n minus 7 into n plus 2 equal to 0. That is either n is equal to 7 or n is equal to minus 2. So it also n must be positive and no whole number. So n is equal to 7. So but n cannot be negative, so that n is equal to 7. Now we got the value of n, and by substituting this value in equation 1, we get the value of a. So substituting this value in equation 1, a is equal to 6 minus 2n, and by substituting n is equal to 7, 6 minus 2 into 7, which is equal to 6 minus 14, and is equal to minus 8. So in that way, n is equal to 7 and a is equal to minus 8. Okay, students. So take the seventh one in third bit. Given L is equal to 28, S is equal to 144, and there are total 9 terms, find A. So here, students, L, that is nth term, is given. The last term is given. And suppose that there are n terms, sorry, it is also given here. So there are total 9 terms. So as L is equal to 28, A9 is equal to 28. And ninth term is 28. And here S is nothing but sum of the given progressions. That is S9 is equal to 144. So we need to find A. So in given progression, number of terms n is equal to 9. Last term, that is L or An is equal to 28. A9 is equal to 28. Also, it is given that sum of these 9 terms is 144. And we have the formula to find sum of n terms is n by 2 into a plus l. So n by 2 into a plus l is equal to 144. Now substitute n is equal to 9 and l is equal to 28. So 9 by 2 into a plus 28 is equal to 144. And by transforming this 9 by 2 to right side, we get a plus 28 is equal to 144 into 2 by 9. And by dividing 9, we get a plus 28 is equal to 916 there. So 16 into 2, which is equal to 32. So that a is equal to 32 minus 28, which is equal to 4. So that's the value of 4. A equal to 4. So this is the end of third bit. So take the fourth problem. The first and the last terms of an AP are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? That's the question. Okay, students. So here we don't know the value of D here. So in given AP, first term A is 17. D also given. Common difference D is equal to 9. And also it is given that the last number is 350. But we don't know the number of terms here. So let the number of terms in the progression be n. So now then an is the last term. And it's given that the last term is 350. So that an is equal to 350. And an is nothing but a plus n minus 1 into d. Isn't it? Now substitute the value of a and d here. 17 plus 9, n minus 1 into 9 is equal to 350. And n minus 1 into 9 is equal to 350 minus 17, which is equal to 333. And n minus 1 is equal to 333 by 9, which is equal to 37. And n is equal to 37 plus 1, 38. So there are 38 terms in given progression. And sum of these 38 terms is n by 2 into a plus l. That is 38 by 2 into first term is a equal to 17 and last term is equal to 350. So 19 into 367, which is equal to 6,973. So therefore, number of terms in the progressions is 38 and their sum is 6,973. Okay, students. Take the fifth problem. Find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. So here the second and third terms of an AP are given and we need to find the sum of first 51 terms. Okay. So it is not given that the first term and the common difference. So let the first term be A and common difference be D. And it's given that second term is 14. Okay, A2 equal to 14. And we know that A2 is equal to A plus D. So that A plus D equal to 14. And from this we can write A equal to 14 minus D and take it as equation 1. And also it is given that third term is 18. That is A3 equal to 18. And we have A3 is A plus 2D. So substitute A plus 2D in place of A3. And from equation 1 we have A equal to 14 minus D. So substitute the value of A in this equation. That is 14 minus D plus 2D equal to 18. Since from equation 1. Now minus D plus 2D is D. And we can transform 14 to right side. So D is equal to 18 minus 14, which is equal to 4. So in that way we got the common difference D equal to 4. And substituting this value in equation 1, we get the value of A. That is A equal to 14 minus D. And we got D equal to 4. So 14 minus 4 equal to 10. So the first term A is equal to 10 and common difference D equal to 4. Now, the sum of first 51 terms. The sum of n terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. So the sum of first 51 terms is S51 is equal to 51 by 2 into 2 into a is 10, n is 51, d is equal to 4. And by simplifying this one, we get 5,610. So sum of first 51 terms of given progression is 5,610. Okay. So let us take the sixth problem. If the sum of first 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of first n terms. Okay, students. So it is given that sum of first 7 terms of an AP is 49 and the sum of first 17 terms is 289 and we need to find the formula to find the sum of n terms. Okay. And in this problem also, the first term and common difference is not given. So take A be the first term and D be the common difference. And the first hint it is given that sum of first 7 terms is 49. That is S7 is equal to 49. And we know the formula to find S7. That is n by 2 into 2a plus n minus 1 into d, where n is equal to 7. And we don't know the values of a and d here. So substitute n is equal to 7. So 7 by 2 into 2a plus 7 minus 1 into d. And transform the 7 by 2 into right side. We remains with 2a plus 6d on left side. And by dividing 7, we get 7 here. So 2a plus 6d is equal to 7 into 2, which is equal to 14. And take 2 common. A plus 3d is equal to 14. That is a plus 3d is equal to 14 by 2 is equal to 7. And from this we can write a is equal to 7 minus 3d. Take it as equation 1. And the second hint it is given that S17 is equal to 289. So again using this formula here, 17 by 2 into 2a plus 17 minus 1 into d is equal to 289. This is the SN formula. And from this we can write 2a plus 17 minus 1, 16 is equal to 289. And we are transforming 17 by 2 to the right side. So it becomes into 2 by 17. And 17 the 289. So 2a plus 16 is equal to 17 into 2, 34. And taking 2 common on left side, 2 into a plus 8d is equal to 34. So that a plus 8d is equal to 34 by 2, which is equal to 17. And now from 1, we can write a is equal to 7 minus 3d. So now a is equal to 7 minus 3d plus 8d is equal to 17. So since from equation 1, now 5d is equal to 17 minus 7, which is equal to 10. And d is equal to 5. So substituting this value in equation 1, we get the value of a, which is equal to a equal to 7 minus 3d. That is 7 minus 3 into 2, which is equal to 7 minus 6 and equal to 1. So now the value of a equal to 1 and d equal to 2. So now we need to find the sum of first n terms. And sum of first n terms is denoted by Sn is equal to n by 2 into 2a plus n minus 1 into d. And now by substituting a equal to 1 and d equal to 2, we get n by 2 into 2 into 1 plus n minus 1 into 2. So again taking 2 common, 2n by 2 into 1 plus n minus 1, and plus 1 minus 1 will be cancelled, 2 by 2 will be cancelled, and we remains with n into n, which is equal to n square. So sum of the first n terms is Sn is equal to n square. Okay. And students, in this problem, we can easily observe that first 7 terms is 49, which is equal to 7 square. And sum of 17 terms is 289 and is equal to 17 square. Okay, S7 is equal to 7 square. S17 is equal to 17 square. In that way, we can easily say that Sn is equal to n square also. But we need to prove here. So for that, we done this solution. Okay. So take the 7th one. Show that A1, A2 up to AN form an AP where AN is defined as below. First one, AN is equal to 3 plus 4n. Also find the sum of the first 15 terms in each case. So two cases are given here. We are looking first case. In first case, AN is equal to 3 plus 4n. And we have to show that A1, A2 up to AN form an AP. And after showing that it is an AP, we need to find the sum of the first 15 terms. Okay. So take the solution. So given that AN is equal to 3 plus 4n. By substituting 1, we get A1. By substituting 2, we get A2. And by substituting 3, we get A3. That is first term, second term, third term, like that. So take A1. A1 is equal to 3 plus 4 into 1. That is 3 plus 4 equal to 7. And by substituting 2 in this equation, we get A2 is equal to 3 plus 4 into 2. That is 3 plus 8 is equal to 11. And similarly, A3 is equal to 3 plus 4 into 3 is equal to 15. A4 is equal to 3 plus 4 into 4 equal to 19, like that. Now, the given pattern is 7, 11, 15, 19, and so on. Okay. Now, we need to show that this pattern is an arithmetic progression. For that, we have to prove that the common difference throughout the sequence is same. So let's find the common difference between each two terms. That is, first take A2 minus A1. A2 minus 7 is 11 minus 7 is equal to 4. A3 minus A2 is 15 minus 7 is equal to 4. A4 minus A3 is also 19 minus 15 is equal to 4. That is, the common difference throughout the sequence is same. So that A1, A2 up to AN form an arithmetic progression. And in this arithmetic progression, first term A is equal to A1 is 7. And the common difference D is equal to difference between every consequent two terms, that is 4. And here we need to find sum of first 15 terms. And we know the sum of first 10 terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. So we need to find sum of 15 terms. So we need to substitute n is equal to 15, a is equal to 7, d equal to 4. That is S15 is equal to 15 by 2 into 2 into 7 plus 15 minus 1 into D is 4. So by simplifying this one, we get 15 into 35, which is equal to 525. So the sum of the first 15 terms is 525. Okay. So take the second one. An is equal to 9 minus 5n. So here also first take A1. A1 is equal to 9 minus 5 into 1, 4. A2 is equal to 9 minus 5 into 2 is minus 1. And similarly, A3 is minus 6. A4 is equal to minus 11. Now, the given pattern is 4 minus 1 minus 6 minus 11. So that now A2 minus A1 is minus 1 minus 4 is minus 5. And A3 minus A2 is minus 6 minus half minus 1 is, that is minus 6 plus 1 is minus 5. And similarly, A4 minus A3 is also minus 5. That is the common difference between throughout the sequence is the same. Hence, A1, A2 up to An form an arithmetic progression. And for this progression, the first term A equal to 4 and the common difference D equal to minus 5. And now sum of first 15 terms is S15 is equal to 15 by 2 into 2A plus the 2 into A. That is 2 into 4 plus N equal to 15, D equal to minus 5. And simplifying this one, we get 15 into minus 31, which is equal to minus 465. So in this problem, sum of first 15 terms is minus 465. Okay, sure. So that's all for today. In next class, we shall complete the exercise 6.3. So until then, see you. Bye.